Now, one of the theories that you singled out was the idea that we are a subatomic particle in another universe. Now, this theory actually becomes fairly logical when you think about what it means to truly be infinite. What do I mean by that? Well, if I take a block of 1 gram of matter and I put next to that an identical block of 1 gram of matter, let's say that somehow I made these two absolutely identical in every aspect, even in the subatomic. I know it's impossible, but let's say we did. What do I have? I have 2 grams of matter. Now let's put another gram of matter in there. What do we have? We have 3 grams of matter. How many boxes does it take before I get to the Tootsie Roll center of the Tootsie Pop? No, actually, how many boxes does it take before I reach the infinite? The answer is not infinity, because if I put infinity boxes of 1 gram together, I have infinity grams. I don't have something that's infinite. The point is that no matter how many finite objects you put together, you will never reach the infinite. The objects themselves must be infinite to begin with. Many people can understand the concept of infinitely large. They can think, okay, it goes on forever in that direction, and it goes on forever in that direction, it goes on forever in that direction. But they can't understand the concept of infinitely small. Let's think of the smallest subatomic particle in existence. Okay? Well, let's rephrase that. Let's say the smallest subatomic particle known to exist. Okay? Some would say it's the quark. It's actually, if you believe in string theory, it would be the string, which is this tiny one-dimensional strip of matter that may be curled around on itself and looped together, or but in any case, it vibrates at a particular oscillation, and then that frequency is what determines what sort of matter it is, whether it's a proton or an electron or a photon or whatever. Okay. Now let's say that that is truly the smallest bit of matter that exists, a string. What have we done? We've just reduced the universe to a collection of strings. We have just reduced the universe to a collection of finite particles. Therefore, the universe is finite. It is not infinite. No matter how many finite particles we put together, we will never reach the infinite. So, my assertion is that if you were able to, which you're not, but if you were able to look into that string, you must find more particles. You must find more existence. You must find more than just the string. An example of this, an example of how this concept sort of works, is this idea of compactification. Now, I know that's an odd word, but that's one way of explaining away all the other dimensions that exist in relation to our own fourth dimension. By saying that if you look at a hose from a distance, or a pipe, it appears to be a one-dimensional line. If you took a ball that is just the right size to fit in that pipe, it will appear to be a point moving across, a zero-dimension point moving across a one-dimensional line. But if you zoom in, if you look closer, you'll be able to see that the inside of that pipe is actually a two-dimensional surface, and an ant crawling on that two-dimensional surface is moving in 2 dimensions. And a fly that's flying through that pipe is moving in 3 dimensions. Okay, it's a great theory. But what people who support that theory fail to consider is maybe we're the fly. Maybe we actually exist in one of those smaller dimensions in relation to a larger size universe. And so that's where you get into this concept of, hey man, you ever think we're like an atom in someone else's eye? Because well, think of a fractal, for instance. A fractal is an example of something that's truly infinite. If you zoom into a fractal, you will continue to get smaller. You'll find smaller and smaller structures, and it'll just keep going. It will never end. It just keeps going. Okay? Now, some people will put up the idea of the Planck length, say, okay, well, no, that can't possibly be true because the smallest matter that can possibly exist is a Planck length. The Planck length is not the smallest length of matter that can exist. It is the smallest length of matter that we can measure. That's the smallest length of matter that we can detect or know anything about. And the reason that is because the only things that we have to detect anything about that matter is a Planck length. So if we take a photon, a high energy photon that's a Planck length, and we shoot it at something that's a Planck length, then the energy from the photon dissipates into the object and turns it into its own black hole, and it sucks the photon in, and you can't get any reading from it. It's not that there can't be something smaller in there, it's that we have no way of knowing. So the fly in the pipe knows that the pipe is three-dimensional. Something inside that object that's a Planck length might know that there's something else in there, but there's no way for us to know it. Now, one way to kind of visualize this concept is, let's go backwards. Okay, a string is part of a photon. Or let's forget about photons. Let's talk about something that's actually directly makes up matter. Let's say if a string is part of a quark, is part of a proton, is part of an atom, is part of a molecule, is part of a protein chain, is part of a cell, is part of a human, is part of a community, is part of a planet, is part of a solar system, is part of a galaxy, is part of a local cluster, is part of a universe. Now, every step along that chain, every single step, we have an object that acts with its own properties. Every single step. A string acts as its own properties as part of a quark, which acts with its own properties as part of a proton, which acts with its own properties as part of an atom, and so on and so forth. Even when you get to the level of the galaxy has its own gravitational pull, its own spin, its own properties. So what is to say that the universe as a whole could not have its own properties that could be observed from the outside as a single unit? So anyway, you asked for kind of an explanation as why people take things like that to heart, why they think that it could be true, even though there's no direct evidence to suggest that it is true. So that was my attempt at explaining it. Keep in mind, I'm not a physicist, I'm not a scientist, I'm more of a philosopher than anything, and I'm just some schmo with a camera who likes to hear himself talk. So I'll let you go. Thank you for watching, take care, have a good day.